Okay, after studying multiplying and dividing rational expressions, we can take a step further into something called complex fractions. In complex fractions, we have the fraction bar right here in the middle. And so this is really just a form of division. We have x plus 1 over x being divided by x minus 1 over 2x. And so even though they look fancy and different, it's really just division. We know that when we're dividing, we change it to multiplying by the reciprocal of the second fraction. So we need to just change that to x plus 1 over x times 2x over x minus 1. And then since we're factoring, we ask ourselves if anything factors. And in this problem, x plus 1 is a binomial already factored. 2x is a monomial, x is a monomial, x minus 1 is a binomial already factored. So I made it pretty easy on us to start with. The only simplifying we need to do is this x will simplify with that x, and our answer would just be 2 times x plus 1 over x minus 1. And there's our first complex fraction example done. Okay, now here the second one has a lot more going on. But again, here's our fraction bar. This is where our division sign is. And we change dividing to multiplying by a reciprocal. So really we need to have x squared minus 9 over 2x, change to multiply by 4x to the third minus 8x over x squared plus x minus 6. Then, since it's now a multiplication problem, we factor everything we can and then look for ways to make 1. Hopefully you recognize that this is an easy set to factor. X squared minus 9, it's just our difference of squares, so x plus 3 times x minus 3. Underneath it, 2x will just stay the monomial 2x. 4x to the third minus 8x has a greatest common factor of 4x. And that leaves us with x squared minus 2, which does not factor. And underneath, x squared plus x minus 6. We're looking for the two numbers that multiply to negative 6 and add to be 1. So we have x plus 3 and x minus 2. And then we look for anything that makes 1. We have x plus 3 and x plus 3. We have x and x. And we have 4 and 2. 4 and 2, of course, don't cancel each other out, but if we think of a 4 as a 2 times a 2, then that 2 and one of those 2's will simplify away. And our answer would be 2 times x minus 3 times x squared minus 2 over x minus 2. The x minus 2 would be tempting to cross off with the x squared minus 2, but because of the extra exponent, it of course does not. Okay, the first two examples are done. At this point, you're prepared to do the first 4 problems on the extension worksheet. And when you're done with those, check back for example 3 here, which will challenge you even further and then help you do problem number 5. Okay, so here is the extra super challenge problem. This time, it doesn't help us to flip right away because there's actually 2 fractions in each place. Before we want to multiply by the reciprocal, we want to combine our fractions. So this is going to take us to a place we haven't gone yet in class. So we're just going to do 1 here. When we return to this idea in class, we'll do more elaborate thought with it. The idea we need to talk about is a common denominator. These fractions need to have a common denominator to combine them before we can change to multiply by the reciprocal. So we think of 2 as being over 1 and 3 being over 1. If we look at our 2 denominators up here, then we have a 1 and we have a y, and we need to make them be the same. So we have to multiply this first fraction by what the second fraction has, but it's missing. So we're going to multiply by a y. If you do something to the bottom, remember we have to do the same thing to the top. So this would become 2y over y plus 1 over y, which would become, remember these are like terms, 2y plus 1 over the common denominator y. So now we just have one fraction. Let's do the same thing to the denominator fractions. This 3 is over 1. It needs to be over y, like the 2 is, before we'll be able to add them. So again, multiply by what it's missing. It's missing a y. If I change the bottom, I change the top in the exact same way. So I've got 3y over y minus 2 over y. And these aren't like terms, so we have 3y minus 2, suddenly a binomial, over y. And then let's put our big fraction bar back in. So now we have our division problem, and we're going to change that to multiplying by the reciprocal. 2y plus 1 over y multiplied by the reciprocal of this one. So y over 3y minus 2. Now that we have a multiplication problem, we ask ourselves for noticing any factoring. Factor first, simplify second. And these are binomials, so no GCFs, no factoring needed. So then simplifying, y divided by y is identical. That equals 1, and we don't need it. And so our answer is 2y plus 1 divided by 3y minus 2. And so that's the first time we ever had to get a least common denominator to combine 2 fractions. We'll do a lot more of that coming up in class. But give number 5 on your extension worksheet a try. And then submit it to Schoology, and you'll be done with your attendance for April 19th. Thanks.